This video will look at another example of a proof using the direct method. So we'll start off and we're going to be asked to prove the following. We're going to say suppose that a, b, and c are integers where a divides b and b divides c, and we would like to prove that a divides c. So notice here, remember a divides b is the same as saying a is a factor of b. B divides c says b is a factor of c, and a divides c says that a is a factor of c. First thing that you always want to do is you want to rewrite this in terms of an if-then statements. So what do you start with? What do you end up with? And here where we start with is we're going to start with a dividing b and b dividing c. Okay. Now, where do we want to end with? This would be our conclusion. So here we're again looking at the format of if p, then q. Where we want to end with is we want to show that a is a factor of c, or a divides c. In this situation, there's nothing preventing us from doing a direct method proof, so we'll just go ahead and do a direct method proof here. So let's put this all together. First of all, when we say our proof, the very first thing you want to do is you always want to state what you're given. So in this situation, we actually are given a couple of things, and it actually turned out to be just a direct copy of that very first sentence. Specifically, this example already gave us, or the question already gave us the symbols a, b, and c. We didn't have to pick our own. They're all going to be integers, and here's the other thing. We are starting at our starting point saying a divides b and b divides c. Yes, I can say that a ton. Now, next thing that we want to do is we want to go ahead and interpret what we have so far into something more useful. Now, a, b, and c being integers, it's awesome, we're totally going to use it, but it's not really something you interpret. So when you're thinking about rewriting or interpreting things, you look for stuff that actually can be rewritten or interpreted. In other words, look for definitions, look for buzzwords, or in this case, we look for our symbols a divides b, b divides c. So when we pull out our definition of something divides something else, this is where we say that, hey, if a divides b, that means a can be rewritten as a factor of b, or we get that b equals a times some other integer k. When we have b divides c, same deal. This tells us b is the factor, so c equals b times some other integer that we'll call t here. And notice when you're using these two other integers, k and t, that came up from our definition of divides, you do need to make sure that you say what they are, that they are here, in fact, integers. Notice, because b and c do not have to be the same thing, a and b don't have to be the same thing, there's nothing that's requiring k and t here to be the same integer. It's totally possible that they are, but it's also possible that k and t are not equal to each other, which is why we make sure to have two different symbols for the k and the t. Now, the conclusion we wanted to get to was that a is a factor of c. In other words, we want to be able to rewrite, so let me put a comment here, we would like to be able to rewrite c as a times something, where that something is an integer. Okay? So what we're going to do next is we're going to see if there's anything we can do to get there, because there's not much more we can do with the definition of divides from the first line. Okay? So we've got c. Awesome. So the next thing we know about c is we look back up on the stuff we already have. We know b divides c. We're like, oh wait, that actually can be written as a formula. So I'm going to rewrite c as b times t. Okay? Now, remember what we want. We want a times something to equal c. We don't have an a yet, so you look at what we do have. We've got the b, we've got the t. Is there any way we could rewrite that to bring in an a? So think about it for a second. And hopefully you're all thinking, hey, b can be rewritten in terms of a. b is supposed to equal a times k right here. So we're going to do that replacement and plug in. At this point, we now have three things multiplied together, the a, the k, and the t. With the parentheses there is an order of operations implied, so let me go ahead and move those parentheses around to make our life put in the right format. And this means we now have written a times k and t. Notice that product kt, we don't care what it is, we only care that it is an integer. Okay? So here's where you got to take a step back. Is that product k times t an integer? Well, both k and t were integers, so if you have two integers to start with, their product is also going to be an integer. So the answer is yes, it is totally an integer, and since that was what we needed, C equaling A times some integer, we have now built up that, yep, we totally have A divides C, and we will use the definition of divides. Some people do like to go ahead and insert this here, of divides. It makes it a little bit more clear what you're talking about if there's any ambiguity there, okay? But not necessary. Now, let me go back in and tag these different sentences. The very, very first sentence was where we grabbed our hypothesis or P statement, and we also defined what symbols we were using, although here we were already given those symbols. Okay? We used the definition of divides to rewrite the symbolic A vertical line B and B vertical line C into what they actually meant. We used our logic and algebra in the middle step to get to what we wanted. We used our definition of divides, and at the end, we grabbed our conclusion statement, our Q statement, to do the final answer down there. Actually, the whole thing is the answer to get to our final conclusion.